Chapter 4.4, Greatest Common Factor, or GCF. So your vocab for today are two words, common factor and GCF, or greatest common factor. So take a moment to write those down, please, and then come back for example 1. So example 1, find the GCF, or greatest common factor, of 18 and 30. So the first thing that we need to do is we need to list all of the factors. Remember, factors are smaller. I like to use a horseshoe factor in order to make sure that I list all of my factors, which looks like this. So 18, I have 1 times 18, 2 and 9, 3 and 6. 4 is not a factor, 5 is not a factor, and now I'm back to 6, so I am finished with my whole list. So if I were to list them, the factors of 18 are 1, 2, 3, 6, 9, and 18. The factors of 30, 1 times 30, 2 times 15, 3 times 10. 4 is not a factor, but 5 is. 5 times 6. 7, 8, and 9 are not factors, and now I'm back to 10, and I am finished. So the factors of 30 then are 1, 2, 3, 5, 6, 10, 15, and 30. So my common factors are 1, 2, 3, and 6. But my greatest common factor is the largest of those, which is 6. So your answer is the GCF, greatest common factor, of 18 and 30 is 6, written in a sentence. Okay, so list all of your factors of both numbers and then identify the largest factor that they have in common. So this is one way to find your GCF. You can use a list of your factors. Example 2 has you finding the greatest common factor of 42 and 56, but this time we're going to use a division ladder. So you saw this in the last lesson. I'm going to do mine vertically. So the first thing I'm going to do is divide by a common factor of 42 and 56. Well, they're both even, so that I know 2 is a common factor. So 42 divided by 2 is 21. 56 divided by 2 is 28. Then I'm going to divide again by the next common factor, which is 7. 21 divided by 7 is 3. 28 divided by 7 is 4. 3 and 4 have no common factors. So now I'm going to take the two factors that they had in common, 2 and 7, and I'm going to multiply them together. And that gives me my greatest common factor. So the GCF of 42 and 56 is 14. So again, you would divide by a common factor. If your quotients also have a common factor, divide again by that common factor until your quotients have no common factors. Then take those common factors that you divided by and multiply them together to find your greatest common factor. So let's take a look at example 3, and this time we're going to find the greatest common factor, but we're going to do it using factor trees. So example 3 is a word problem. A volunteer divides 18 adults, 27 girls, and 36 boys into groups to clean up the park. He divides the adults, girls, and boys equally among the groups. What is the largest possible number of groups he can make? So the first thing I'm going to do is make my factor trees for each number. Remember, a factors tree is looking for its prime numbers. So 36 is 9 times 4. Neither of those are prime. So we have 3 times 3, which are both prime, and 2 times 2, which are both prime. So 36 is 2 times 2 times 3 times 3. 27, 9 times 3, 3 is prime, 3 times 3 equals 9, so 27 equals 3 times 3 times 3. 18 equals 2 times 9, 2 is prime, 9 is again 3 times 3, so 18 equals 2 times 3 times 3. So now that you have the prime factorization, now you're going to identify the common factors. So I'm actually going to rewrite these just a little bit. I'm going to put this 3 over here. Okay, the reason I'm doing this is because I want to line up my numbers. And we're going to put this one over here. And you'll see why in just a sec. Okay, so I still have 18 equaling 2 times 3 times 3. 27 is still 3 times 3 times 3. And 36 is still 2 times 2 times 3 times 3. But the reason I lined them up the way that I did is because I want to identify the common factors. So I see that this 3 is a factor in all 3 numbers, and this 3 is a factor in all 3 numbers. This 3 is only a factor of 27, not 18 or 36. And these 2's only are in 18 and or 36, but not in 27. So this 3 and this 3 are in common. Then I'm going to take them and multiply them together. 3 times 3. So the greatest common factor is 9. Okay, so the largest number of groups is 9 groups. Now notice, I'm not multiplying all of these 3's together. I'm just multiplying this factor, which is a 3, and this factor, which is a 3, together. I'm not multiplying 3 times 3 times 3 times 3 times 3 times 3. I'm just multiplying 3 from this column and 3 representing this column in order to get 9. Okay, that's it for 4.4. Complete your QCs and your CYU, and we will go over this the next time I see you.